question?
You may.
Can you tell me which direction down is?
Whichever way the plumb bob hangs.
What do you mean?
Well, if I have a weight on a string, that's down.
Okay. And that weight,
Buoyancy is down.
Hold on. That weight on a string, if we move it, let's say 100 feet to the left, is that the same down?
Not parallel, no.
Not parallel. So we have different downs.
Yes.
Okay.
How long have you been here, I see?
Okay. I'm not done. I'm not done. I have another question.
Yeah.
So we take one of those down vectors, right?
Mm-hmm.
How far can that go? How far can that
mean?
down vector go?
Like inside the Earth, you mean?
Presumably to the center, right?
Or center of mass, at least, yeah.
So it'll go to the center. The down will go to the center of your Earth, your sphere.
Yeah, center of mass.
Yeah.
Okay, and if once it reaches that center, if it continues in the same vector, what happens?
Then it'll be now up.
So the down becomes up.
Yeah, once it passes through the center of mass, yep. Now up.
So what happens? What happens to you? Like when you enter that, you're entering feet. How are you entering? Feet first, head first? How do you envision entering the center?
Feet first, I guess.
Sorry?
Feet first, I guess.
Feet first. And when you get to the center, what happens?
Well, now your head's, if you go through the center, now your feet are up and your head's down.
So you do a 180 at the center.
Well, you don't move.
You don't
rotate.
move?
No, you don't rotate. You just pass through the center of mass.
You said your feet would now be up, see?
Yeah.
So if you come out the other side, you would be doing a headstand.
Yeah.
Yep.
So you're saying without turning, you would end up right side up on the other side?
No, you'd be upside down on the other side.
I was saying your head would be on the ground.
Land on your hands. On your
Wouldn't
head.
there have to be a pocket of no gravity there? Where it's
You have to crawl around.
Let him finish one question at a time.
This is ridiculous.
It is.
He answered it, SE. You'd be on your head, your hands. Your feet would be up in the air on the other side.
He did answer it? Oh, okay.
Yeah,
Okay, cool.
Roohif's
Nice.
cool about that. No matter how dumb it seems, he just says it to other people try and kind of, because it sounds ridiculous, but that's how it actually would be on their model. You would have to be pulled out from the other side, from the center, pulled up by your feet.
Yep.
To come out the other end.
Exactly.
You'd hit the bottom point, then you'd have to crawl around to the other side of the middle and stand up.
Do you see anything wrong with that?
No, you have to get down. No, you have to get up. No,
Okay.
down. Oh my God, this is so embarrassing. It's
Down to
confusing.
get up.
Not bad.
We're gonna down you up.
It was good earlier, but now it's
Kind of
Yeah.
dragging.
So Roohif, seriously,
Yeah.
how about
They-
in the center? How do you envision the center?
They
Of
say
your-
if you
There'll
fell,
be
you
points.
would orbit, SC.
There'll be a point of zero gravity there.
In the center, you're with the zero gravity crowd. You float in the center.
Center of mass. Yeah, there'll be a center
Okay.
of mass. So
All
there's
right.
zero gravity.
Yeah.
Moryak said you would come back to the surface because of gravity, and then you would go back down.
If
I
you
forget what
fell
he
all
told
the
you.
way, if you fell from the surface, you would.
Yeah, if you drop down that hole to the center, it would push you back up to the surface, and then you would fall back down again. I guess until you I don't know, lost energy.
Roohif,
And
Down
in the
is
middle.
everywhere, then, right? Down is everywhere
Down is everywhere.
for you.
Down is the direction of a hanging weight.
Especially if
And
the
where is
bitch is
And where
if
is
the
that
bitch
on
is
your
spinning.
model? Where is that on your model?
Points towards the center of mass.
So down is everywhere.
If you interpret that as what I said, sure.
Okay. All right. I'll pass the mic now. I think I said enough.
You couldn't have got through that question with anybody else with less pushback.
Yeah.
You know what I'm saying? He answered it.
I agree, but I got a problem because
I
center
gotta
of
give him
mass,
kudos.
everything's attracted to zero G.
Yes, that's how it works. So whatever is at the center of this ball Earth doesn't feel any gravity, or rather,
Yeah, if you
to put it more correctly, it feels tidal gravitational forces, they call it, because if you're at the center of the imaginary ball, you're gonna be like the gravity is gonna be pulling you outwards. It's gonna pulling you to every direction.
Yep. They
Roohif,
used to tell us we'd be ripped apart. That's why they said we would be ripped apart at the center of the earth. Y'all no longer say that though, right? It would just be pulling you.
right? But wait, Roohif, if I put something in a centrifuge or if I spin anything, what's going to happen to the denser items if I spin them?
Flung to the side, yeah.
Yeah, they're going to go to the outside or the surface, whatever you want to call it. So, what's at the center of Earth?
Molten iron core, I'm told.
A nickel.
Why didn't it come to the? There's no gravity there at the center, and it's denser and it's spinning. Why didn't the iron come to the core, man? I mean, come to the surface like everything else.
Don't forget it's spinning too, Brian. The center is spinning too. The Earth is spinning, and the center of the Earth is rotating. That's something people forget.
Right. The mass, the molten iron core or whatever, has a huge amount of gravity because it's a huge amount of mass, whereas the centrifugal force is very small compared to gravity.
Sorry, no, but we just agreed that the more towards the center of the Earth that you go, the less gravity there is, and at the actual center there is no gravity.
Yeah.
There's also less centrifugal force.
So the center should be pulled to the outside.
When you're at the center, you've got equal amounts of mass all around you. So the net force is zero.
The net force, the net direction of force
Is zero. Right, but you'd be stretched apart.
Yes, you will be experiencing maximum tidal forces.
Yes.
You're going to be experiencing maximum differential forces at that point.
Why?
Because all the mass that you have around you, every bit of mass would be pulling you towards its own direction.
It would be like a different atmospheric pressure, but I know it wouldn't be the atmosphere, but it kind of is. I mean, it's your environmental pressure would be different. Is that what you call it, buddy? Tidal forces?
The plumb bob vector, Roohif, the plumb bob vectors that you said are pointing to the center, that's what would crush you in your model. You'd be toast.
If you're at the center of the Earth, no, there'd be nothing. There'd be fuck all force.
But you just said you float in the center.
Yeah, but because it can't switch. You got to float because it can't switch. It can't go from one direction to another without a spot in between. So their model is a fucking paradox in itself.
That's the word, Brian. You took it out of my mouth. Paradox.
Let's say you're 6 feet tall, right? And the center of your body is at the center of the Earth. And you've got your head 3 feet away and your feet 3 feet away in the other direction. Are you saying it'd be pulled apart? Like literally broken in half?
Well, maybe not ripped apart, but your head is going to be pulled towards your ball's north pole, and your
it'd be a Lagrange point, bro. It'd be a Lagrange point type of thing.
Yes. Well done, Brian. Yes. The center of mass would be like a Lagrange point.
No, it will be experiencing
maximum. But that's what makes it a paradox.
What are you falling into his trap for? By Lagrange point. That's
what makes it a paradox.
Nah, it doesn't. You'd be crushed. The center of mass pulling you to the center. That's their whole freaking gravity bullcrap. Come on, guys. Don't fall for this.
Your head 3 feet away from the center is going to have fuck all force on it.
According to your own model, you'd be crushed like you'd be a super diamond. Okay?
No.
Super diamond.
Yeah.
Super nano diamond.
You'd come out sparkling.
Yeah, being mistaken about it does not make it a paradox.
Oh, left lane. There you go, buddy. So when you go down deep in the ocean, does the pressure force inwards or outwards?
Yeah. It's not that much pressure, but it would be different.
You're not in a hole,
it's not that much
You're not
pressure.
in a hole there, are you?
No, you're lower than the surface of Earth. So the lower you go, the more the pressure goes inward or outward, left lane.
With all of that water on top of you.
Yeah, with all the Earth on top of you as you go further down into Earth.
If you're in a hole, you don't have the dirt on you.
Yeah. I was assuming all this time we're in a hole, aren't we? You dug a hole.
Oh, you're assuming the center of the Earth is a hole now. It's a
No,
spinning.
we dug a hole. We dug a hole through the center of the Earth. That's how this whole thing
Yeah,
started.
that's what we're talking about.
I'm not being
Yeah.
crushed by a fucking.
Oh, so all of a sudden the hole you dug will alleviate all the pressure? Is that what you guys are thinking in your head somehow?
Well,
Like
So
a
we're just
balloon?
talking fantasy, right? So
They're in
obviously
fantasy
you
la
can
la
only dig
land.
a hole less than 8 miles. You're definitely fantasy world digging a hole to the center of the Earth. Then you were talking about a fantasy if you could dig a hole to the center of the Earth and go down there. You're not going to be crushed by the walls of the hole. The hole's going to stay there. There's no inward pressure now because we did a
This is not
fantasy
my
hole
thought
to the
experiment.
center of your Earth. This is fantasy talk. Even Left Lane is going, yeah, but the hole you dug to the center of the Earth isn't going to crush you because you dug a hole. Well, first of all, you can't dig a hole because the pressure is so great, it would cave in. And if you did reinforce it with some magical power that you think you have that would keep that hole from crushing in, once you went down there, you would be at the center of the Earth doing what again? Floating?
Which
Floating.
part of this?
You're
Which part
you're
of this
bringing
was
up very
not a
good
thought
points.
experiment?
Yeah, you're bringing up very good points that in reality would be true. You can't dig a hole to the center of the Earth. This is a thought experiment.
Yeah, because
But
there's
SE
too much
brought up.
pressure.
But doesn't mean you got to get lost in fantasy, Left Lane. Let's keep the
Yeah,
thought experiment as real as possible.
you think maybe we brought it up to prove to y'all that it is fantasy? That maybe there's not a center core made of molten iron or whatever the hell y'all say now that's also
Nickel.
spinning and nickel that creates this magical pull downward towards the center. But once you get there, there's no opposite reaction of force. Like I
Oh,
don't even know what
Jesus.
to say, dude.
Just
Excuse
saying
me,
I don't know how to
everywhere is
explain net
down.
forces. I
it's
don't know how to
solid
explain net forces to
liquid
Raqia.
iron. It's solid liquid iron. It's like, I mean, it's there's no end to it.
You
And
mean
it's
solid
magnetic
liquid.
too, remember?
They say
Magnetic,
If you're on the
molten,
surface,
spinning,
Yeah.
Past
rotating
the
nickel.
Curie point, but
if you're on the
magnetic.
surface of Earth, which direction is the mass?
Which direction
Down.
is down?
Yeah, the direction of the center of mass, right? If
There
you're
you
in the
go.
middle,
You have to say that, bro. You have
if
to.
He
you're
has
in,
to. Yeah,
if you're in
yeah.
the middle of the Earth, then you have equal amounts of mass all around you, so there is zero net force. But
I
if
don't
you're on
think
the
that.
surface, if you're on the
Nope.
surface, then the mass is below you.
I think when I get to the
Incorrect.
Rocky, I think when I travel across the Rocky Mountain plains and I'm standing next to that mountain and the mountain is to my west, there's more mass to the west than there is to the east of me, and there's more mass below my feet than there is above my head.
Yeah.
So there's
That mountain-
masses in different directions.
Yeah, that
Yeah,
mountain
it's not
will have
equal
a
amounts because
tiny,
it's an oblate spheroid.
tiny effect.
Wait, so gravity's got to be the strongest on the
On the surface.
once you
Yeah.
go down. Once you go down, the further you get toward the center, you're working your way down to zero, and
Yeah,
the
you'll have
big switch.
Yeah, opposing
Let me
directions,
tell
right?
the
You'll-
people listening what he's saying. He's saying that on the bottom of the elephant, when the elephant is on top of you, it's lighter. When you're on top of the elevator, it's heavier. The
Correct.
elephant, I mean. That's what
Yeah,
he's
for the
saying.
record,
It's
ladies and gentlemen,
unbelievable,
that's-
man.
that's not what he's
It's
saying.
beyond belief. Like, you seriously got, like, under the elephant is lighter. On top of the elephant is heavier. That is what you're saying, dude.
Oh, it's just your misunderstanding, as usual.
Huh? It was pretty clear. I mean, I've heard some weird stuff come out of y'all's mouths, man, but it really, when you really start breaking it down, each little part is super like fantasy inflated. Like,
Right.
I,
And if you really think about it, dude, like so in a black hole, the would be the strongest, and like the fucking there'd be a spot of no gravity inside of a black hole or a fucking quasar where a teaspoon
Yeah,
of
that's
water
exactly what I was thinking, Brian.
Yes.
where a
black
teaspoon of
hole
water
and a
weighs
quasar.
4 billion tons.
Come on, man.
The center of mass
Bro.
will have net force of zero.
Oh, okay, you say that for the first time, but I corrected you for the third time, but I corrected you the first time. You're saying it wrong. So it's not the net force that is zero, but it's the net direction of the force that is zero.
It's the same
You're
thing.
gonna... No,
Same
it's
thing.
not.
Net direction.
Because,
If there's no
because,
direction, there's no vector.
because not
So we
having
would-
forces, not having forces acting on something may have the kinetic effect, may have the same kinetic effect as having two opposite forces, but equal forces acting on something. So
So we
Yeah,
the
would.
the net
kinetic,
force is zero.
just give me 15 seconds.
Yeah,
So the kinetic result of those two cases will be the same. The object will not move. In the first case, it won't move because it has no forces acting on it. On the second case, it will not move because it has two equal and opposing forces acting on it.
So we wouldn't get
But-
spaghettified. We wouldn't get
but-
spaghettified. We get fucking meatballed.
Hang on, Brian.
Yeah, exactly. But in the second case, you have tidal forces acting on it.
Do
That's
you
not
guys know
net
how
force
diamonds?
being zero.
Do you guys know how
Right?
diamonds are formed?
That's forces.
Compression.
That's forces canceling each other. If it's solid and it can withstand the stress, it will sit there and it will not move. But if it's a fluid, it will start drifting in every which way.
When
see the
said
difference now,
direction,
Roohif?
when you said that it has no direction, right? A force is a vector, right? It has a direction and a magnitude, right? If either one of
Yes.
those is zero, then the other one is zero. Like if it has no direction, then there is no magnitude. If it has no magnitude, there is no direction.
Yeah, but you said that this theoretical object at the center of the theoretical Earth is experiencing all the mass around it, each tiny chunk of mass pulling it to its own position, right?
But net force
Which is
zero.
away from where it is, right?
Yeah.
So that's a lot of forces. That's not a zero force. That's all of
Net
the forces,
force,
all possible.
Net force. Net force is zero. Net force.
So all those
Yeah, that
tons
doesn't-
and tons of rocks and earth equally pressing together, all this huge whatever we're on, you're saying that cancels out to zero.
There'll be a point at the center of mass which has a net force of zero.
I hope people are
he's just-
listening. I just hope sensible people are
They-
listening.
they-
That's all.
That's in a whole essay. That's not talking about the pressure of the ground, at depth doesn't have pressure on it. It's kind of like, it's got all the ground above it, push it down on it. If there was a hole down there, there wouldn't necessarily be this great force on you that would squash you. You would just, be floating in the hole.
Flame, you can't seriously think that, bro. You just can't.
Yeah.
Come
That's
on.
how it works, SE. This
Okay,
is
let's
basic physics.
bring in the other paradox too, right? So Roohif.
Yeah, hang on. What was the first paradox? What was the
So
first
yeah,
paradox?
so this you agree that the more you go in deep into the ocean and deep into the earth and deep into the atmosphere or whatever, you get more pressure, right?
Yep.
Yeah, you get more stuff pressing on you because of their weight, correct?
Yeah, but then as you get closer to the center, there will be a point where the net force is zero.
Cool. So how much will the pressure be at the center of the earth?
At the center of the earth, zero.
At the center of the
center
earth,
of mass will be zero.
And the pressure?
Zero. Pressure is force per unit area. There'll be zero force.
No nano diamonds, super diamonds then, because it's
Not at the
zero.
center of the
No
earth,
super diamonds for you. No soup for you.
Yeah, so
No
there is zero
diamonds are not at the center
pressure.
of the earth.
Okay, so there is zero pressure at the center of the ball Earth. That's what you're saying, right?
Yep. Center of mass will have zero pressure, zero force.
Awesome.
Yes.
This is unbelievable, guys. Anybody listening to this with like scruples in his head must be saying, "What the hell did I just hear?"
Can you type that in chat? Roohif, can you type that in chat if you don't mind? At the center of Earth, zero gravity, zero pressure.
I'm just floating in the hole.
Center of mass of the Earth. There is zero net force, 0 net pressure.
He's typing net. He's typing
zero net? Yeah, net force. Is that gravity in your eyes?
Yeah. What other?
Yeah, put parentheses gravity behind it. I don't mind you using net force, but
So wait, so it's a
People go.
vacuum. Now he just made it a vacuum, a perfect
yeah,
vacuum.
Brian, let him go, buddy. This is
He
awesome.
just made the center of Earth a perfect vacuum with no pressure, with no gravity. Where I just picture fucking like Ed cartwheeling around like Mario.
But y'all don't even think there's a center to the Earth. So
Well,
I mean, how
don't
can
bring
you
this back
argue
to us.
against it?
This is y'all's ridiculous model.
Oh, okay.
I mean, this isn't even the nearest craziest thing y'all say. I mean, this is just one part of it, but I do want to have it. Like, I'm tired of people. I'm tired of people 2 weeks from now going, "Oh, Roohif wouldn't have said that." I mean, no way, Roohif said that. And Left Lane going, "Oh yeah, I was there, guys. Roohif, y'all are misleading, and that's not what Roohif said."
Do you want to
Yeah,
get
I'm tired of
Carnivore
that
or
bullshit.
J-Ace to repeat it in the chat?
No, I'll read it.
J-Ace has got a physics degree, I think.
No, I'm good with
Carnivore,
what
I'm
you
pretty
said.
sure is a pretty smart guy.
Hey, it could be true. I don't know. I just want, like I said, 2 weeks from now, I don't want someone saying, even if it's not true or true, it doesn't matter. I just don't want Left Lane backing up Zanuck going, "I'm sure that's not what Roohif said. I'll have to talk to him."
You can screenshot it. It's there
Thank
in the
you.
chat.
Yeah, well, guess why I got you to type it out. Thanks for telling me I can screenshot it. Thanks, man.
Yeah.
I hope it's true for you, man. I really do
Like,
want you to have your ball.
Carnivore says, "Is Vector Edition yet another kryptonite for FE?" Yes, apparently it is. And
Hey, don't
JA
forget
says,
what-
So at the center of every Roohif, so at the vacuum.
I
Don't
mentioned
forget
nothing
Roohif.
about a vacuum. I didn't say anything about a vacuum.
You said zero pressure, dude. What are you talking about?
Yeah, I don't mean fucking atmospheric pressure. Just 0 force per unit area. Just force.
It's a floaty zone, Brian. It's a floaty zone.
How is atmospheric pressure different than this pressure?
Oh, you get like, what is a vacuum? If I stick a rock in a vacuum, is it still a vacuum? I don't know. If I stick some gas in it, it's clearly not a vacuum. But if I stick a rock in a vacuum, do I have a rock in a vacuum or not a vacuum anymore? I don't know.
Well,
what's your
I would
definition?
guess. I would guess that you will get some. You will get some pressure, because part of the gas that is in the rock will just fuck off into the vacuum.
Okay.
So, yeah.
Okay, I didn't mention gas in my original comment, so yeah, I'm just talking
Yeah,
about
but
net
then the
force,
pressure
net
will not be. But the pressure will not be zero pressure. That's the thing. So that's a paradox that that I hope you can see. It's yet another of the paradoxes of the ball Earth idea.
No, regardless of whether that's gas or solid, there will still be a point of net zero force and therefore net zero pressure. You can't have net zero force and some positive pressure. That's impossible. Pressure is force per unit area. So if force is 0, then pressure is 0.
Yeah, I fully understand, and I'm fully aware of why you must support this, right? But I'm just because you're clearly more educated in physics than the rest of the, let's say, ball supporting crowd that frequents this place.
Look, JS
But
is here, Extremis is here, Carnivore's here, Kosho's here.
Right.
Anyway, fucking Howard's here.
Yeah. Anyhow,
any glober here disagree with what I've said?
Anyhow. So my point is that I hope that you, the man, understand and can see how this is a paradox regarding reality. Like, if you juxtapose what you must support right now, what you just said, and your everyday experience of forces, pressures, net forces, net pressures. I hope you can see how this doesn't jive, the one with the other. That's all.
Roohif, at the center of Jupiter or gas giant would be a perfect vacuum, right?
Perfect vacuum. I wouldn't say that.
At the center of a gas giant, where there's no rock.
There'll still be a point of zero force and zero pressure.
So
But
a perfect vacuum on a gas
you're
giant.
talking about a volume. It's not a vacuum. Why do you keep bringing vacuum?
Because zero pressure on a gas giant.
Zero pressure is a vacuum, right, Roohif?
Zero gas pressure, I would call a vacuum. Like I said a minute ago, if I have a
That's
volume
what he
of
said,
space,
a gas giant.
right? Then I would say
Gas
no, it's not a
giant,
vacuum.
zero
I would say
pressure.
it's not a vacuum, right? Not a vacuum at the center of Jupiter. Oh, there we go. So Chuki Brad Boy has said Roof is correct.
Not zero pressure then.
Oh, okay. Let me.
But it's a gas giant, Roohif. It's a gas.
I understand.
Giant.
I understand.
Yes.
It's a gas giant. Okay. There is a volume at the center of Jupiter, which has gas particles in it. That is not a vacuum. Okay. Not a vacuum. There is a point.
So there is pressure.
But it has zero pressure.
There is a point inside that volume which has zero force and therefore zero pressure.
And gas.
Yes, and gas. Yes.
Okay.
Where would that be? At the dead center?
Say again?
Where would that be? At the dead center?
Well, the center of mass.
It would just be a point, which doesn't exist.
The dead center, like right at the dead center is where you're saying that's going to be?
If you assume like a uniform distribution of mass, then yes.
Isn't that what you're assuming? By saying
I've
net
always
zero?
said the center of mass.
I know, but you're saying net zero. Isn't that what you're assuming?
No, like our Earth has like an uneven distribution of mass, right? So the center of mass is not necessarily at the like geographic center of the Earth. It's probably not.
But it still would be net zero at some point?
At some point, there is a center of mass and the net force will be zero.
Maybe not at the very center, though.
Maybe not. Probably not.
So, same, and the same with Jupiter, which is a gas giant, which implies that it's made out of gas.
Yes.
So at the center of Jupiter, maybe not its geometric center, but its center of mass, its gas mass, there will be a point where the pressure of that gas will be zero.
Yes.
All righty then. And you don't see any problem with that. You don't see any
problem with that at all. Brian gets confused with what a vacuum is. That's not a vacuum.
Say again?
There's gas particles.
No, did I use the word vacuum? I didn't use the word.
No, that was Brian. That was Brian.
I attributed it to Brian as well.
Yeah, but I borrowed his idea because I think it was a brilliant idea with a gas giant to make an example to give the example of a gas giant. So we got a gas giant planet, and borrowed from Ball World, and there is, you say, at the center of its mass, like there has to be a point which is full of gas, and the pressure is zero at the same time. Those things happen at the same time.
You have a volume of gas, all right, and a point with zero force or pressure.
Or pressure?
If you have zero force, then you have no pressure.
Why did you use or? You mean force?
Zero force.
Pressure.
If you have zero force, you have zero pressure.
Okay.
Let me ask you, what's keeping the ball intact? The ball of gas intact?
Gravity.
Gravity, and there's zero pressure?
At a point near the center of it, yes.
But switch to near the center.
Well,
that is an oxymoron.
If we assume perfect distribution, then yes, at the absolute center. Happy now?
But don't they say that? Don't they say that the way Jupiter is, the reason Jupiter has the form that it has, they say, it's because there is two competing forces, they say, at play. So there is a tendency for the material that makes up Jupiter, those gases, there's the tendency to implode and collapse, right, out of their own weight, gravity, as they say. You with me? Yeah. Right? Then they don't collapse all the way down to the size of a proton or whatever, but but they sit at the diameter of whatever the diameter of Jupiter is supposed to be, because there is what preventing them from collapsing?
The size. The size isn't big enough for it to have enough gravity to basically force itself into a sun. It's not big enough to be a sun, basically.
And what is preventing it from collapsing further and becoming smaller in size?
Not enough gravity and too much molecular force, I guess. That's a question for J.A. Reckon or Chronic.
Too much pressure, you mean?
Well, force. Yeah, okay, yeah, sure. Force or pressure.
Yeah. So these two are competing, right? So there is the gravitational force that is not a force, but we can think of it as a force that is collapsing Jupiter. It's trying to make it smaller, and at some point it finds resistance, and it cannot make it smaller anymore. And this resistance is because of gas pressure, right?
Well, molecular forces, I would have thought.
What do you mean molecular forces?
Well, the strong and weak nuclear force. I might be talking way out of line here, by the way, so JA's correct me in the chat.
So are you saying that Jupiter does not collapse because the nuclei of the matter is preventing it from so is there a point in the depths of Jupiter where the nuclei of the gases that make up Jupiter are shoulder to shoulder with each other? Is that what you're saying?
Oh yeah, there'd be points in Jupiter that would be under extreme pressure. Yes.
I thought that was called the neutron star. I didn't know that gas giants work like that. That's new to me.
Not a neutron star.
Sure? Are you sure about what you're saying now? Or
Jupiter is not a neutron star. Yes, I'm sure of that.
Say again?
Jupiter is not a neutron star. It's not big enough to have that enough gravity to
Okay.
So let me ask you this, Roohif. If the surface of Earth is the place with the most gravity, so we got to go through a bunch of atmosphere, and then we hit like the surface of Earth, and because if we start going lower, then we start canceling out forces. But so what on Jupiter? On Jupiter, where would be the strongest gravitational spot there?
I'm not sure
if it's all gas.
I'm not sure the surface would be the strongest gravity.
Well, there would be no surface of Jupiter.
Okay.
You know, you guys are in a mythical place, right? That can't exist.
Yeah, that's fun, dude.
You
come up with a paradox every 5 minutes, bro. No matter how he answers, I got a paradox waiting for him.
Don't ask us what happens on our model and then criticize us for giving you fucking answers.
Right. I mean, that's the thing. That's what I'm saying. I mean, y'all are criticizing something that you don't even believe exists.
Bro, I'm literally having fun, man. Don't get excited, bro.
I think it was a
in the chat. Is it the nuclear force that sort of prevents fusion from gravity?
Yeah, that's in the case of a star. So that's the criterion of whether the gas giant is going to ignite and become a star. And Jupiter obviously does not do that. Well, obviously, in quotes, bunny ears, air quotes, NASA stuff.
Go ahead.
Yeah. So I'm saying that I'm trying to establish, actually, to be honest. So all of the rest of you are not bored. I'm trying to establish if Roohif has been informed that it's gravity against pressure working on Jupiter. So it's a hydrostatics problem. This is how gravity is
causing the pressure. Gravity is causing the pressure is the force.
Yeah. So there is a balance found, though. I mean, Jupiter is not shrinking or getting bigger, right?
Right. It's reached equilibrium.
Hey, can you give me 1 second? Oh, I got one more paradox to throw at him. So on Earth, if we're going down in the ocean, okay, according to the way you're describing things, there has to be a flip, and it's got to be gradual. If forces are if there's net zero forces, then the further we go from the surface, the less gravity and the less pressure, to where we hit a spot in the middle that's zero net pressure, zero net force. So we start going deep down in the ocean, and we start. At what point does the pressure start getting lower, like the way you're describing? Because
I'd have to do the maths for it.
Well, we start going down, and we get like 5 miles down, and we got a lot of water above us. gravity would start pulling back at us, and so like at some point it would have to even itself out, but it would have to gradiate to that position. It would have to gradiate. It can't just flip all of a sudden. If you're talking about net forces, it's got to gradiate. So, I mean, I'm wondering. I'd be curious if you could do the math and tell me at what point would the pressure start turning around, like at about 10 miles, maybe 11 miles.
I have no idea, but yeah, you understand the basic premise, right? The gravitational force is proportional to r squared, right?
Yeah, but but you don't see that as a paradox, man, and everything about your model.
Once you go down below the surface, you'll have some mass above you and less mass below you, right? So there is a calculation to be done. I don't know what the answer is. Maybe someone can stick it in the chat. But yeah, like it'd be interesting.
Yeah, well, you're saying more mass, less pressure. That's what you're saying.
That's exactly what he's saying.
Yeah, I know.
Yeah.
That's why
the deeper the less pressure. The deeper you go, the less pressure.
Because
That's exactly
he's
what
saying,
he's saying.
I mean,
and you
he
float
has
in the
to say
middle.
that. He has to say that because he must, like everyone, like that's not personal. Like everyone who says that must defend the position that the mass that you're gonna have, like the stuff that you're gonna have above you, the stuff that you're gonna have above you is gonna be pulling away pressure from you. That's what they have to support.
You're asking us what would happen on our model and then criticizing us for answering your questions about what would happen on the model.
I mean, how do y'all think it should work?
Bro, once again, bro, we're just asking questions, man. Don't get uptight.
Can you guys hear me?
And we're highlighting the paradox, right? Like in the case of Jupiter, it's two things competing against each other. So
hang on one second. Whoever's asking to be heard,
it's
rough, man.
But it's rough, yeah. It's rough, Coach. But we.
Well, I'm only going to speak for half of a second. I got to turn this fan off, but here. Okay, no, very quickly. That's really better. Very quickly, because I just got. We say the calculation Roohif is looking for is actually fairly simple. If you're on a sphere like Earth, obviously to calculate your mass on the surface or your weight on the surface, you do the equation he said. So the mass of the Earth, your mass, and the distance between you and the center.
R squared function.
No, right. But to do the equation for what your weight would be down below the surface, all you have to do is treat the Earth as its. So you have to take. So you still use your radius, whatever. It's gonna that radius is gonna decrease, of course.
Yeah, but the masses are already canceled out, though, bro.
But in order to cancel out the mass, in order to do the equation correctly, all you have to do is treat the Earth as a ball that's the size of the radius that you're now using.
Yeah.
So
can I ask everybody? Can I ask you a question?
You subtract the mass of. So basically, you use. So let's say you go down to your 3,000 miles. That's your new radius. You now imagine that you're on a ball that is only that size. So you got to calculate the mass for all that size.
Yeah. Okay.
What's the outcome?
Right, but I think the point. I think there's a point that keeps getting missed here. Right. Let me give you an example, Coach, please, and just tell me where I'm missing this. Okay. You know how you make a snow angel in the ground and you lay down on the ground and you're just like laying down. Okay, so you're just chilling, right? Okay, you're not going anywhere. You're just sitting there on that same spot in the ground, right? Now, you remember in Braveheart when they fucking drawed and quartered the guy or whatever, and they tied the rope to each of his fucking arms and legs and then pulled that motherfucker apart? Right? Remember that shit? Okay, like, he was laying there just like the snow angel, but, like, he wasn't going anywhere because all the forces were equal, right? He wasn't going nowhere. But it wasn't really the same situation, was it?